Hello student. So today we will do the last lecture of amines. The topic for this one is basicity of amines. Okay, so let's do basicity of amines. Now this basicity of amines is divided into two parts. Basicity of amines in gaseous state and next one is basicity of amines in aqueous state. Okay, now before we start this, let's do some let me write the list of some important points. Okay, always remember EWG decreases basicity of amines. Okay, this is your first thing. Second thing is that ERG increases basicity of amines. So if there is any ERG attached to amine group, okay, amine compound, then it will always decrease the basicity, and if it is ERG group, then it will always increase the basicity of amines. Okay, now what are the list of EWGs and ERGs I have given in previous chapter also. So the same ERG list: NF3 plus, NR3 plus, NH3 plus, NO2, CN, COOH, CHO, fluorine, bromine, iodine, C triple one CH, then C6H5, that is phenyl, and lastly you have this CH double one CH2. Okay, among them from here till here it's important. I'm marking it. These ERGs are extremely important, and then this phenyl is also extremely important. Then what about the list of EWG? Sorry, ERG. So in ERG you have this NH2, then OH, then you have OR and R. Okay, so you already know what is OR and what is OH. So just information, OR is actually alkoxy, right? And R is actually alkyl group. So if I give you some examples of alkoxy, let's say OCH3, then OCH2, CH3 means O and R will be there. And alkyl means made up of carbon and hydrogen like CH3, CH2, CH3, etc. Got it? Now, there is one more relation that you have to remember. This is a very important relation. So here, this acidity is a relation between acidity and basicity. So acidity is inversely proportional to basicity, and it is directly proportional to Ka and inversely proportional to Kb, and it is directly proportional to pKb and inversely proportional to pKa. Actually, in this chapter, sometimes they ask relations of Ka, Kb or pKa, pKb. So what you can do for that, you first find the order of basicity, and then depending upon this relation, you find the order of Ka, pKa, or whichever they ask. Alright, now we are done with this. So we'll start with the first part of this basicity, that is basicity of amine in gaseous state. Okay. Now always remember one thing: as the number of alkyl group increases, so alkyl group is actually ERG. As the number of alkyl group increases, basicity of amines increases. Now based on that, what you can do, if I arrange it in terms of alkyl, so let's say you have one amine that is 3 alkyl group. Its basicity will be more than one alkyl that has one amine that has 2 alkyl group, and its basicity will be more than alkyl that has an amine that has one alkyl group. Now if you pay attention to this one, and then lastly you have this NH3, there is ammonia that does not have any alkyl group. Now if you pay attention to this part, can I say this one is 3 degree, this one is 2 degree, and this one is 1 degree aliphatic amine? Yes or no? So you have to remember it like this. Okay. Now why in the presence of alkyl basicity increases? So always remember this alkyl group is ERG group, and they will specifically ask you that what is the reason. Okay, so if they ask you reason, so alkyl group is ERG group and it shows plus I effect. Okay, you just have to write this. Now what is this plus I effect? Is called electron donating inductive effect. Okay, you just have to write this. So that's your first point under basicity of amines in gaseous state. Okay, we'll explain this one properly, but let me cover the second point. Second point says that as the number of phenyl group increases, basicity of amines decreases. Now when I'm talking about phenyl group means C6H5, okay, which can also be written as this one, and this phenyl group is actually EWG. Okay, so from before also you know that I have given the statement: if EWG is connected to amine, then its basicity will decrease. Now if I arrange it, then it will be NH3 as usual, ammonia. Then its basicity will be more for that amine that has one phenyl group, or its basicity will be more for one amine that has two phenyl group, and then its basicity is more for that amine that has three phenyl group. Okay. Now if I arrange this one, so I can say this is 1 degree, this one is 2 degree, and this one is 3 degree amine, right? But what type of amine? I will say it's an aromatic amine. You know what is aromatic amine and what is aliphatic amine, right? So in aromatic amine, nitrogen will be directly connected to benzene ring. Yes or no? Yes. Now if I combine this point number A and point number 2, point number B, that aliphatic and aromatic case, can I say that I will get a combined relation of like this R? Okay. Now, if I combine both the things, so I can say that aliphatic amine, and then you have this ammonia, and lastly, from here to here, you have this aromatic amine, right? With this, I came to the conclusion that aliphatic amine is always more basic, or it has more basicity than aromatic amine. Yes or no? So always remember, in general, aliphatic amine basicity is more than ammonia, and its basicity is more than aromatic amine. Okay, so that's your first point. So I have explained many things, so you just have to remember this note point. All right. Okay, let's do some example. So some example, suppose I'm giving you CH3 3 times N. Next example is benzene ring NH2. Third example is CH3 2 times NH. Fourth example is this one. Now question is, give the order of basicity of amine. Okay, now what you do, the first point what you should do, you should always arrange it in terms of this relation. Okay, so you first arrange them in terms of aliphatic and aromatic amine. So I know that this is my aliphatic amine and this one is another aliphatic amine. Okay, that's because here nitrogen is not directly connected to benzene ring. So I know that A and C will have more basicity than B and D. Done. So this part is what? Aliphatic. And this one is aromatic. Now we will do internal arrangement with respect to degree. Okay. So this one what degree? It's 3 degree, right? Because here nitrogen has only one hydrogen and here it is 2 degree. Sorry, my mistake. In the first case is 3 degree because here nitrogen has no hydrogen. And option C is 2 degree because nitrogen has one hydrogen. Now, based on this, what I can see, what was the order? In case of aliphatic, it was what? In case of aliphatic, it was 3 degree more basic than 2 degree than 1 degree. Yes or no? And in case of aromatic, 1 degree is more basic than 2 degree and then 3 degree. So based on this rule, I can say that A is more basic than C, right? Then between B and D, they are aromatic, right? Let's do it with different color. So they are aromatic, right? So this one I can say is 1 degree aromatic and this one I can say is 2 degree aromatic. So clearly B will be more basic than D, right? So that's the order of basicity. So order of basicity is A will be more than C, then B will be more than D. Yes or no? Let's do another question, right? Let's say this is the question. You have to give the order of basicity of the following amines. Okay. So now, so let's say I'm giving you this one. nitrogen, BNH3 nitrogen. This is aromatic. And then this one you have CH3NH2. So always remember, it does not matter whether it is like the alkyl part. If you clearly notice, if you see here, it's CH3, CH2, and then here it is CH3. So it does not matter whether alkyl in alkyl part number of carbons are same or different. You just have to arrange them in terms of aliphatic and aromatic. So the red marked one, they are aliphatic because here nitrogen is not directly connected to benzene ring. Yes or no? So I can say that A, C, and F, they are aliphatic, right? Then we have this ammonia, right? So obviously it will be in middle. And lastly, D and E, they are aromatic in nature. Yes or no? Now you identify the degree of aliphatic. So we are doing degrees of aliphatic. Okay? So this one is 2 degree, right? And this one is obviously 3 degree because it does not have any hydrogen with nitrogen. So this one is 1 degree, right? So based on this, I know that in aliphatic case is 3 degree, 2 degree, 1 degree. So I can say I will arrange it. So it's C, A, and F, right? And then B. Between D and E, what I can say, this is what, 1 degree, and this is 3 degree, right? In case of aromatic. Now we're doing for aromatic, these two. They are aromatic. These two are aromatic, right? Now since they are aromatic in nature, then always remember, in aromatic case, it is always 1 degree, 2 degree, and 3 degree. So I know that D will be more basic than C. No, E, sorry. Right? Clear? So that's the order of basicity. Okay? Clear? Now, there is one category of basicity of amines. Pay attention. You can say these are mixed aromatic amines. Now, why it is called mixed aromatic amines? Because it has it has alkyl and phenyl connected to nitrogen of amine. Yes or no? Let's take one example. Suppose I am giving you CH3 and CH3 and this one. So this is aromatic, right? Because your benzene ring is directly connected means it falls under this aromatic case. So and then let's say NH is given and then CH2, CH3, does not matter what alkyl they have given. It can have, like this is the alkyl part, right? Yes or no? It can have 2 carbons also. It does not matter. Now, how we will get the basicity of this one? How we will get the order of basicity? So always remember, here also same rule. As the number of alkyl increases, okay, then basicity increases, and as the number of aryl increases, basicity decreases. Now, how we will check it? Chalo, let's see this. If I pay attention to this, these two are alkyl, right? So here I can say 2R is there, and this one phenyl is there. Yes or no? And here only one R is there, and one phenyl is there. Yes or no? So in which case the number of R is more? This case, first case. So the first one basicity will be more than the second one. Let's do some example so that it becomes clear. But here it's not only alkyl, we have to focus on the aryl part also. Let's do this question. Suppose question is CH3 and CH3, this one, A, B, CH3, CH2, N, then this one, then third one is CH3, CH2, N, H, this one. So suppose I'm giving this, right? So what was the rule? As the number of alkyl increases, basicity will increase. As the number of phenyl increases, basicity decreases. So let's try that. So here, if I circle this 2, it has what? In this case, it has 2 alkyl that I'm representing with R and 1 phenyl pH, right? Here, can I say it's 1 alkyl and 2 phenyl group? These are the phenyl groups, okay, pH, and this is 1 alkyl. And here it's 1 alkyl and 1 phenyl, right? So in which case the number of alkyl is more? Obviously A, so A basicity will be more. Now there is a tie between B and C in terms of alkyl, because this one also has 1 alkyl and this one also has 1 alkyl. It's okay, then we'll check number of phenyl. But what was the rule? As the number of phenyl increases, basicity decreases, right? So here it has 2 phenyl and this one it has 1 phenyl, right? So 1 phenyl means C basicity will be more and then it's B basicity. I hope it's clear. Okay. So you will apply this logic, this trick in case of mixed amines. Okay. So where both alkyl and phenyl they are present. So you will calculate or you will count the number of alkyls and number of phenyls. Okay. Let's try one question. Let's say this is CH3, CH2 and H2, then CH3 3 times nitrogen, D, CH3 2 times nitrogen, and then this is this one, then D is NH3, E is CH3, CH2, nitrogen, hydrogen, and then one phenyl, right? F, CH3, not CH3. Let's take this one. So basically here you have this one and this one, right? And lastly you have this structure. Okay, so how to do this? So first of all, same rule, aliphatic, ammonia and aromatic. Okay, what are the aliphatics here? This is first aliphatic, this is second aliphatic, right? Then there is no other aliphatic, so I know that A and B will have more basicity, and this is our ammonia, right? This is your D, and remaining everything is aromatic because here in all the cases nitrogen is connected to benzene ring. Yes or no? So I can say it is C, E, F, and G. Right? Now, among that, there are pure. Always remember, okay? Like if it's mixed aromatic amines, okay? Mixed aromatic amines basicity will be more than pure aromatic amines. Pure aromatic amines means there is no alkyl In them only phenyl is there. So I can say these two are pure aromatic. These are pure aromatic or not, right? Yes or no? So I know that F and G's acid basicity will be less than that of C and E, which has mixed, they are mixed aromatic. Okay, this one is also mixed aromatic. Clear? Now between A and B, I can say let's do for aliphatic part. Okay, let's do for the aliphatic part first. So between A and B, I can say this is 3 degree and this one is 1 degree. So definitely B basicity will be more than A and then D. Okay, let's do for pure aromatic. This one is what, 1 degree, not 1 degree, I'm sorry. This one is 2 degree and this one is 3 degree. So definitely 2 degree will be more basic than 3 degree. So I have arranged it. Now between C and E, okay, let's focus on it. In C, what is happening? If you focus on this structure, there are two alkyls and one phenyl, yes or no? And between E, in E, you have one alkyl and one phenyl. So in which case number of alkyl is more? Obviously, in case of C, is alkyl is more. So C basicity is more. Okay, so that's the order of basicity. Okay, clear? This one is very important. Basicity of mixed aromatic amines is always more than pure aromatic amine. Okay, I hope this concept is clear, right? Now there is one more note point that you have to remember. So let's say if there is any 1 degree amine, aliphatic amine. So 1 degree aliphatic amine is basically RNH2. Its basicity will be more than for a case where is also 1 degree but one benzene ring is connected and its basicity will be more than NH3. Okay, this one case. Got it? So let's do one example based on that. Suppose I'm giving CH3, CH2 and NH2. Okay, and then you have this benzene ring connected and then you have this CH2 and NH2 and you have this NH3. So this one is basically RNH2 case, right? And this one is basically this benzene ring connected to R and then NH2. Yes or no? And this one is pure ammonia. Right. So what will be the order of basicity here? So here order of basicity will be A is more than B and B is more than C. Okay. Got it or not? Clear? Alright. Now let's do another. This is your first note point. I hope it's clear, right? Okay. Let's do another note point. In this case, let's say this is your B. NH3 is given. Its basicity will be always more than this case. It's an aromatic amine, right? It's an aromatic amine, and then this is a pure aromatic amine. Okay. This one I don't think we have to do. Okay, no need to do this because this one we can explain it with the third point. So I hope you understood this one, right? This point. Okay. Now there is last type where they ask basicity with respect to the substitution at ortho and para positions. Okay. So if there is benzene ring like aromatic amines is given and ortho and para position some substitutions are there, then how you will calculate the basicity? Let's do that. So It's a type, right? Now try to understand. You have to remember this, like NH2. So this one is if there is any ERG at para position, then if there is any ERG at meta position, if then this one, it's a normal aniline, okay? And then you have any ERG at ortho position, okay? And then you have EWG at meta position, then you have one EWG at para position, and lastly you have one EWG at ortho position. Okay, so you can just remember it like this. This is para ERG, then meta ERG, then it's a normal one, okay, then it's ortho ERG, then it's meta EWG, para EWG, and lastly you have that ortho EWG. Okay, just remember this. This is a type where aniline will be given at ortho and para position, substitution will happen. And if you notice carefully, like this one, it's all 1 degree aromatic amine, okay? Let's do some question so that it becomes clear to you, right? This relation is important. So let's do this question. Suppose I'm giving you NH2 and it's OCH3, okay? Then NH2 is given. Then at third one is given NH2, NO2, and at fourth position you have given, it's given the fourth molecule, it's F. Okay. So first of all, you have to identify that does it belong to that first category where aliphatic and aromatic amines I have to substitute, or it's a case of mixed aromatic amines. So clearly in this question it's not the first two case. So actually this question is based on this type that I have explained now. So you just identify what are the things given here. So this is my ortho ERG, okay, right? This is my normal condition, right? This is my para EWG, and this is my meta EWG, right? Now you just have to use this relation. So out of this, which one comes first? Normal comes first, right? If you can see here. So this is B, then comes ortho ERG, right? So it's A, then comes para EWG, then it's C, and lastly you have that. No, my mistake. This will be meta, okay? Because meta comes first and then para. So D and then C. That's the order of basicity. Okay, I hope it's clear. Right. I'll rub this and I will do one more question so that it becomes clear to you. So you write this question, okay? Let's say I'm giving another question. NH2 CN NH2 CH2 and CH3 NH2. You have OH NH2 and then normal one. Then how you will find this? So this one is basically what? This is para EWG, right? This is para ERG. This is ortho ERG, and there's the normal one, right? So based on this relation, I can say that this para ERG is this one. So B will have highest basicity. Then you have this normal case. That's your D, followed by C, that is ortho ERG, and then lastly you have that para EWG. Okay, so that's your A. That's the order of basicity. I hope it's clear, right? Now, with this, we're done with basicity of amines in aqueous state, not aqueous, sorry, gaseous state. Now we'll move on to the second part, that is basicity of amines in aqueous state. Basicity of amines in aqueous state. Okay, so they will always mention aqueous state, or they will mention in place of aqueous state. What they can do, they can mention AQ like this along with the amines formula. Okay, so here is very simple. So if it's only applicable for aliphatic amine, okay, okay, and here also the rule is same. Aliphatic amine is more than ammonia, and then it's more than aromatic amine. Okay, rule is same, but here they mainly ask question on aliphatic amine. Okay, that also in aqueous state. So you just have to focus here. The first one is, let's, this is aliphatic amine, right? And you already know 2 degree, 3 degree, 1 degree. So R3N is 3 degree, right? Which can also be written as RN, R, and R. So this is 3 degree amine, yes or no? Then R2NH, I can also write this one as RNHR. So it's 2 degree amine, right? And RNH2 is what? Yes, simple. RNH2 is 1 degree amine, yes or no? So always remember, in case of aqueous state, here if R is CH3, okay, so the order of basicity will be 2 degree, 1 degree, and 3 degree. Okay, that's your first case. Clear? So what's the meaning of this? It's something like this: CH3, CH2NH will have more basicity than CH3NH2, and then CH3 3 times nitrogen. But in which state? In aqueous state. Okay, I hope you understood this. So they will ask reason for that. Okay, what's the reason behind it? So you have to write the reason. They generally ask reason. Okay, no steric hindrance to hydrogen bonding. Okay, thus hydrogen bonding dominates plus I effect of alkyl group. Okay, you have to remember it like this. Now, let's say that here only two types of question they will ask. In one case, alkyl will be CH3. In another case, alkyl will be C2H5. Okay. So, let's say if here R is CH2CH3, or which can also be written as C2H5. Okay. So, in this case, what's the order of basicity? order of basicity in aqueous state, it's 2 degree, 3 degree, and then 1 degree. Okay, so it means CH3 CH2 2 times NH, it will be more basic than CH3 CH2 3 times nitrogen, and that one will be more basic than CH3 CH2 and H2. Now they will ask reason for that also. Okay, so what will be the reason? Reason will be presence of steric hindrance to hydrogen bonding. Okay, and thus plus I effect of alkyl group dominates hydrogen bonding. You just have to write this reason and you will get full mark. Okay, okay, now they might ask some extra questions also, so that we will do as note point. So what's the order of steric hindrance? Order of steric hindrance, okay, in different degrees of amine. So it's always remember, it's always 3 degree amine will have more steric hindrance than 2 degree and then 1 degree amine. Okay, so if you want to write it in a normal way, R3N, then R2NH, then RNH2. Clear? That's the order of steric hindrance and plus I effect both. Okay, then they will ask another question like, what's the order of hydrogen bonding in different degrees of amine? So it's 1 degree, 2 degree, and 3 degree amine. Okay, so you can also write it like RNH2, then R2NH, and then R3N. Okay, clear? So you have to remember this. So the like small miscellaneous questions. Okay, so with this we're done with this chapter. We'll do some questions now. Okay, let's start with this question. Question number 30. Okay, but this question number 30 is saying, it's saying that among this compound, give the decreasing order of basic strength. So basic strength means they're asking basicity, yes or no? Now this one is not clearly the first category where pure aliphatic and pure aromatic is given. This is also not mixed aromatic compound, right? So it's the third one, right? Third one in basicity of amine. But now you have to be careful that whether this question is based on aqueous state or not. So in the whole question they did not mention anything about aqueous state. Yes, right? Question number 30, they did not mention anything about aqueous state. So definitely this question is not from aqueous state. And on top of that, in aqueous state, either CH3 will be given or C2H5 will be given. Now, so this one is clearly from the third type in basicity of amines in gaseous state. So what's this? So NH2, then this one is given and NO2 is given, right? And then NH2, CH3 is given, and then this one is NH2, and then this one is given, right? So clearly this one is what? Para EWG. This is para ERG, and this is your normal case. So if you arrange it with that list, you will find that this is your structure 1, this is your structure 2, and this is your structure 3. So structure 2 will have more basicity if you compare it with that list, structure 3 and then structure 1. I hope you understood this. So based on this, there is only one option which is correct. It's A. That's the order of basicity. Alright. I hope this question is easy. Now if we do question number 31. So what they are saying. Which of them among the following which is the strongest base? And here again they did not mention anything about gaseous state. Yes or no? Right? So what's this first structure? Here substitution is also there. Okay. So let's see. This one I'll try to first arrange it in aromatic case and aliphatic case. Aromatic. Second structure is also what? CH3 and then benzene ring. And this one again connected with NH2. So this is also aromatic. Right? Third one. Okay, benzene ring is given, but if you notice carefully here, NH2 is not directly connected to benzene ring. Yes or no? NH2 is not directly connected to benzene. So this is aliphatic, okay, actually. And last one is ONO2N, that is NO2, is given NH2. So this one is again aromatic. So there is one option. You know that in general, always aliphatic amine is more than NH2 and then it's more than aromatic amine, right? So my answer will be aliphatic. So that's my option C. So my answer for this one will be option C. Okay, got it. Let's do this question. Question number 32. What they're saying? Which of the following is least basic, right? Least basic is what? What was the order of basicity? I know that aliphatic, then you have NH3, and then you have aromatic. Yes or no? So based on this, I know this one is, the first one is aliphatic, this one is ammonia, and lastly this one is also aliphatic, right? Only this one is aromatic compound. That structure C is what? It has NH2 and that is directly connected to benzene ring. So this one will be your answer because it is aromatic and they won the least one. Yes or no? So this will be the one. Okay. Now question number 33, what they're saying. Question number 33. C2H5 2NH is more basic than C2H5 3 nitrogen in aqueous state. Okay, so whenever it is aqueous state, be careful. So you search that what is R here. R is C2H5. Based on this, my order of basicity in aqueous state will be 2 degree, 3 degree and 1 degree. Yes or no? So definitely yes, 2 degree, because this one is my 2 degree. It has only one hydrogen. This one no hydrogen, so it's 3 degree. So definitely my assertion is correct. Okay. Now what they are saying, this one has more steric hindrance and plus I effect than this one. So definitely, what was the order of steric hindrance and plus I? Steric and plus I. It was 3 degree more than 2 degree and then 1 degree. Am I not? So definitely this C2H5 twice NH is saying that is more steric hindrance than C2H5 3 times N. So this is 2 degree and this one is 3 degree, right? So definitely not possible. So my reason is wrong. So only one option is correct. That is option C. I hope you understood this. Right? Try question number 34. So question number 34, what they are saying? They're saying that out of the following, the strongest base in aqueous. Okay, so always remember they have mentioned aqueous. So aqueous means R can be CH3 or R can be C2H5. Always, okay, in your syllabus. So here they have given methylamine. So first one is methylamine means CH3 NH2. Second one is what? Dimethylamine. So CH3 two times and right, NH, right? Third one is trimethylamine. So CH3 three times N. And fourth one is aniline. So aniline is NH2. So in aqueous phase also it follows the same thing. Aliphatic and then NH2 and aromatic. Yes or no? NH3 and aromatic. So definitely this one is aromatic. This option D. So out of the box. Now since it's CH3, so C2H5 is out of the box. So based on this, I can say the order will be 2 degree, 1 degree, and 3 degree, right? So which one will have the strongest basicity? So this is what degree? This is my 1 degree, this is my 2 degree, this is my 3 degree, right? Definitely 3 degree and 1 degree is out of box, so only 2 degree. Okay. So my answer for this one will be this dimethyl aniline. Okay. So like this, many questions are there. Let's do question number 37. Okay. After that, we'll move on to one more variety and then that's it. With this chapter will be over. All these questions are same, okay? They use the same concept. Let's do question number 37. Question number 37, what they are saying? Increasing order in gaseous phase, okay? So if they don't mention anything, then also it is gaseous phase. If they mention gaseous phase, means it's gaseous phase. But for aqueous phase, they will always mention. Keep that in your mind. So don't solve any question in aqueous phase if it is not mentioned in the question. So now this one was the structure C2H5 gaseous phase. Okay, remember this is gaseous phase. So this one is N and then they have given C2H5 and H2 and this one is what? C2H5 twice NH. Then definitely this one is gaseous phase and it's a case of pure aliphatic. Okay, all are aliphatic in nature, right? All are aliphatic in nature. Then what will happen? We know that in aliphatic case, what is the order? Is 3 degree is more than 2 degree and then 1 degree. Yes or no? So I just have to find the degrees. Okay, so let's find it. This one is what? Can I say it's 2 degree? Then this one is 1 degree and this one is 3 degree, right? Because it has no hydrogen. So what will be the order? So they are asking increasing order. Increasing means small to big. Okay, so small to big means it will be 1 degree first. So C2H5 and H2, then C2H5 twice NH, and lastly you have C2H5 three times of nitrogen. Okay, that's the order. I hope it's clear. Correct, right? So that's your answer for question number 37. Other questions are same. Let's do this question that has different concept. This one, okay. Here they are asking the answer of pKb, like order of pKb. Now what you will do, you always find basicity for amines, okay. After that you try to get the relation of pKb. I know the relation of basicity with pKb is inversely proportional, okay. You use that list, that relation that I have given at the starting part of this class. So first we will find basicity, okay. Now this one they did not mention anything, so no, it will be gaseous state, right? It's gas phase question, right? So what is the meaning of C6H5NH2? C6H5NH2 means what? This is benzene ring and NH2, right? C6H5 is always benzene ring. The next thing is CH2H5 and H2, and then you have this NH3. If it's in gaseous phase, and this is a case of pure aromatic and pure aliphatic, so what was the order? Aliphatic amine, then NH3, and then aromatic amine. So just get the basicity order in rough, okay, rough calculation. So this one I know that it's ammonia, this one is aliphatic, and this one will be aromatic in nature. So based on this, can I say what is, like, my rough work is done, okay? I'm now writing the order of basicity. So what's order of basicity? I can say that C2H5, then NH2. This is all rough work that I'm doing, okay? And then NH3, and then you have this C6H5 NH2. Because the C6H5 is what? Is this thing. Then what will be the relation of pKb? So pKb relation will be reverse. So you write the same thing, but just reverse it. C6H5NH2. Yes or no? Now you read. This is your rough work. All a rough work, okay? Like step by step. Once you practice this question, you can do it very fast. But now I'm just explaining it in a very simple way. Now they want the answer in decreasing order. Decreasing means what? More to big, right? So in pKb relation that you have, what will be the decreasing order? This is your actual answer that you are writing now. This is your answer, okay? Decreasing means always big to small. Which one is more value? So this one definitely, right? This one, right? So I'll write C6H5 and H2, right? Then next one is NH3, and then lastly you have C2H5 and H2. So that's your final answer. Okay, so I hope it's clear. So with this, we're done with this chapter. You can solve all the questions of Amine chapter now. Okay, all right, student. Thank you.